Okay, here we're asked to find the x-intercepts with their multiplicity and then find the y-intercept also. Okay, so let's jump right in here. So for the x-intercepts, we're going to need to factor. If it's not already factored, we have to factor. So both of these have an x, so I'll factor out that x. So x squared minus 1 is what's left over. Okay, and then we can factor this thing too, to x and x minus 1 and x plus 1. Okay, and since they're all set equal to 0, you either have a 0 from the x, a positive 1 from the x minus 1 factor, and a negative 1 from the x plus 1 factor. And since there's no powers on any of them, they all have a multiplicity of 1. Okay, this one, on the other hand, notice this one has a power of 3. So when x equals positive 2, this one has a multiplicity of 3 because that's the power up there. Then x also equals negative 1 from the x plus 1 factor. Okay, 16, the first thing we're going to have to do is factor this fourth degree like we would factor a quadratic. So this factors to x squared minus 9 and x squared minus 1. Okay, if it's a fourth degree and then a second degree and a no degree, you factor it just like a quadratic, only your x has a square on it. So we can factor both of these still, x plus 3, x minus 3. And even this one to x minus 1 and x plus 1. Okay, so you get a negative 3, we get a positive 3, we get a positive 1, and we get a negative 1. All with multiplicity of 1, since none of them have any powers on their factors. Sorry, this is a 1. So now we're looking at these two rational things. Okay, for rationals, your x-intercepts come from your numerator. Okay, but there's a little bit of special things we have to do. And first of all, check to see if anything cancels out. So if we factor the top, that's x plus 2 and x minus 2. Okay, and on the bottom, this one factors to x minus 2 and x minus 1. Okay, so notice the x plus 2's cancel out, or the x minus 2's rather cancel out. Okay, where we would have had a x-intercept at positive 2, that means instead we're going to have a hole. So there's only one x-intercept, and that is at the point negative 2, 0. Or x equals negative 2 as your intercept. Okay, the multiplicity is clearly 1. There's only one factor of that, so it's going to have a 1. So that's our only x-intercept. Okay, likewise with this guy. This one, we're going to factor out that x first and have x squared minus 6x plus 9, okay, which factors to x minus 3 squared. Okay, so here we're going to have a 0 as an intercept, right, from our x, and then a positive 3. So 0 has a multiplicity of 1, and positive 3 has a multiplicity of 2, because once again, there's that 2 on that power, on the factor. There's a power on your factor. So now let's go back and find all the y-intercepts. That's pretty easy. Plugging in 0 for x. 0 and 0, we have a y-intercept of 0. Okay, plugging in 0 for x, we have negative 2 cubed, right? Negative 2 cubed is negative 8 times 1. So negative 8 is the y-intercept here. Or maybe 0, negative 8, if you want to be exactly exact. We'll write it as a point. Okay, over here, when we plug in 0, this one's gone and this one's gone, and we're just left with a 9. So 0, 9 is the y-intercept for number 16. Okay, 0, 0, and 0. So negative 4 divided by 2 is negative 2. So this one has a y-intercept at 0, negative 2. Okay, plugging in 0 for everything. That one's gone, this one's gone, the third one's gone. 0 over negative 16 is 0. So this one has a y-intercept at 0, 0. Okay, so to find the x-intercept, you factor everything. Okay, for rationals, see if you can cancel things out. And then the y-intercept, you just plug in 0 for x, and you see what you have left over.